video, I want to talk about specific heat. So I want you to think about keeping a metal belt outside in the heat and water out in the heat for, let's say, 5 minutes. When you go back, chances are that the water has not heated up very much, whereas the metal belt is almost melting. Why is this the case? I mean, we see this in sort of land versus water heating as well. So the land heats and cools really quickly, whereas water or the sea heats and cools really slowly, wherein in August you go to the ocean and it's still not very warm. The difference really is this concept of specific heat. What is happening is that the water has a very high specific heat. So in general, I need you to remember that water has a very high specific heat. On the other hand, something that does not have a very high specific heat would be the metals that we talked about, the metal belt, for example. So these have lower specific heats. So what does specific heat actually refer to? So there is a definition and there is a formula and there is a symbol. So we will refer to specific heat as C. It's the amount of heat energy needed to raise the temperature of 1 gram of a substance by 1 degree C. So if I had 1 gram of water and I wanted to raise it from, say, 37 degrees C to 38 degrees C, that is through 1 degree, the difference being 1 degree, that I would need as much energy as a specific heat. And the specific heat of water is actually 4.18 joules, so I would need to put in 4.18 joules. Joules is a measure of energy, remember? And that is how much I would need to put in to heat it from 37 to 38 degrees C. Specific heats of some substances are shown here. You can very clearly see that the aluminum, for example, which is a metal, has a low specific heat, whereas something like water has a higher specific heat. You'll also notice two different units for specific heat. One is the calories per gram Celsius and the other is joule per gram Celsius. We will mostly stick to the joule per gram Celsius values. Here's a problem that I wanted to work through. How many calories are needed to heat a pot of 600 grams of 1,600 grams of water from 25 degrees C to 100 degrees C? The important thing here is to remember the equation Q is equal to mc delta T, where Q refers to the heat, and that answer is going to be in joules. M refers to the mass, and you will put that answer in grams, or the unit will be in grams. C is the specific heat that I have introduced, and for water it will be 4.18 joule per gram Celsius, and this is a constant for a given substance, and delta T is the difference in temperature. So in this case, they are asking how many calories, so we need Q. We've been given M, 1,600 grams. You've been given C, it's 4.18 joule per gram Celsius. And the delta T, or the difference in temperature, is 100. That's the final temperature minus the initial temperature. So delta T is 75 degrees C. So now that I know all of the stuff that I need for this equation, I'm going to substitute it. Notice that the way that they've done it on the PowerPoint slide is a little bit different, and I will talk to you about the differences and how we can eventually arrive at the same answer no matter how we do it. So we're using this Q is equal to mc delta T, 1,600 grams times 4.18 joule per gram Celsius times 100 minus 25, which is the 75 degrees C. Degree C gets cancelled. Grams gets cancelled. So you are left with this. Get an answer of 50,100, 600, and that is in joules. Now they've asked us for calories, so we would need to go ahead and convert. So the answer that we got, and you should be putting this into your calculator, I get 501600 joules. And since they've asked us for calorie, I can very easily convert that to calorie by multiplying by 1 calorie is 4.18 joules, or dividing by 4.18 joules. And when I do that, again, do these as I talk to you about them, you get 120,000 calories. It's the same answer that they have gotten here, except that notice what they used. They used the specific heat not as 4.18 joule per gram Celsius like the way we did. We got our answer in joules and then converted it to calories. You could use the calorie number directly and then get the same answer. Okay, so the moral of the story is really pay attention to units, because in this case what you're getting is calories, and that was what they were asking in the question. But you could have gone with the joule per gram Celsius unit for the specific heat, gotten the answer in joules like we did. That was the answer of 50,1600 joules. And then when we converted it, we got 120,000. And those of you who are wondering, how is this? Think back to scientific notation. What we're doing is we're moving the decimal point 1, 2, 3, 4, 5. And so we're getting 1.2 times 10 to the 5th calories for an answer. Thank you.